Here we're given a function f of x equals x to the fourth minus 4x cubed. We're asked to find the inflection points on all the real numbers. We're looking for the values of x where concavity changes from concave up to concave down or from concave down to concave up. That's what it means to be an inflection point. We're first going to take f of x and we're going to factor it. Now, I thought about that, after I did this problem. I thought, what the heck am I factoring f of x for? It's not really necessary. It would be cool if you're going to go on and graph the darn thing later. But for now, it's not really going to be a contributing factor here. Okay, now take the original function x to the fourth minus 4x cubed. Find the derivative, 4x cubed minus 12x squared, using the power rule, and factor that sucker. Now you really do want to factor that one. You get 4x squared times x minus 3. Now take the derivative of that, the second derivative, and factor that. You get 12x times x minus 2. Now draw a number line and partition the number line with the zeros of f prime and f double prime. Okay, so we're going to put a point at 0 and a point at 2 and a point at 3. See, the 0 and is a 0 of f prime and f. The 2 is a 0 of f prime and 3 is a 0 of 2 is a 0 of f double prime, 3 is a 0 of f prime. Okay, we've got them all there, the zeros of f prime and f double prime. Now, figure out what the sign, positive or negative, is in each of those regions. Now, you've got your factored form of f prime. Just substitute a value of x in for a value less than to the left of 0. You get plus times a minus gives you a minus. And for the second derivative, you get a minus times a minus equals a plus. Now, the first derivative being negative means you have a negative slope. So you have a decreasing function of f. And the second derivative being positive means you have concave up for the original function f. Okay, now in the middle region, let's figure out the sign of the factors for f prime. Positive times negative is a negative, and then the second derivative has the signs positive times negative is a negative. So the first derivative being negative means you have a decreasing function, the slope is negative, and the second derivative says you have concave down because it's negative now. And this is all features. These are features of the original function. In the next area, we have the sign of f prime being negative. The sign positive or negative of f double prime is positive. The first derivative being negative gives you a decreasing function, and the second derivative being positive gives you concave up in this region. Finally, in the last region, we figure out the sign, positive or negative, of the first derivative. It's positive, and the second derivative, that will also be positive. So this time we have an increasing function since the first derivative is positive, and we have concavity up because the second derivative is positive. Now, where did that come from? Where did we get this idea? It's using notes number 77 and note number 81. 81. Okay, 81, not 82. Let's go back and review those notes. Okay, now we're ready to apply note 82. So we'll be able to draw our conclusion reading note 82, and that is the inflection points. When we change concavity, we get an inflection point. Now, we change from concave up to concave down at x equals 0, so that's an inflection point, point of inflection, pi. We change from concave down to concave up at x equals 2, that is a point of inflection. Okay, but for this last point, x equals 3, we didn't make any changes in concavity. We went from concave up to concave up. That is not a point of inflection. So our 2 points of inflection occur at x equals 0 and x equals 2.